Hi, I'm Pat Kelly. Okay, and in this problem, we're instructed to use separation of variables in order to find the general solution to this differential equation. So for my first step, I'll want to do that act of separating. I'll do some algebra to separate the variables, all the y's on one side, all the x's on the other. In this case, I'll just end up with y cubed dy equals x minus 1 dx. First step, separate the variables. The second step would be to do the integration of each side. I'm going to have the integral of y cubed dy equals the integral of x minus 1 dx. Even the step that we just took there, it's kind of like a golden rule in algebra, is you're allowed to do whatever you want as long as you do it to both sides of the equation. So we decided to integrate both sides of the equation. Now I'll do that integration on each side. Y to the fourth over 4, x squared over 2 minus x, and plus the constant of integration. And I'm going to take one more step here, just because that's maybe a little unsightly with that y to the 4 divided by 4. I can clear the entire equation of fractions by multiplying by 4. So this is just going to simplify to y to the fourth 2x squared minus 4x plus, and I'm multiplying by 4, but I'm catching this that it's going to be 4 times c sub 1, which is still a constant, so it looks a little neater to just write plus c. You might have seen this in some of the work in the book, is that constant of integration that I did write down, I included the subscript just even in anticipation of the fact that I was going to do another algebraic step and that I'd have a constant at the end that I'd want to use my c for. I don't want you to stress about that. Thinking ahead that there's going to be that c sub 1 rather than just a c is not something to worry about at all. In fact, I'll show you even at this point in your work, if you had gone to do the integration, y to the fourth over 4 equals x squared over 2 minus x, and if right then you're thinking of the regular old plus c, that's what we would be thinking, but then you're going to do that extra step to clean it up. Multiplying through by that 4 gives us the same expression, of course. And that would be 4, this last constant would be 4 times the constant above. And it's really the only point of the subscripts is to distinguish them. So when I was telling you not to stress about thinking ahead with that subscript of 1, if you take this approach, just go back and put that subscript. So you're thinking of the plus c with integration like you usually would be thinking, and then at the end you're realizing that that's not the same c, so I'll just distinguish them with subscripts. Okay? In either case, that's the right answer. And I'm also going to tell you that that last step that we took in either approach, that was just to kind of clean it up and make it look better. Might not really even be considered a necessary, essential step. It just looks cleaner, and I would kind of chalk it up to mathematical etiquette. Looks nicer, so we'll do it that way, and it's kind of one of those things that maybe if we're nicer to math, math will be nicer to us. Okay, so there's our problem. Thanks, and I hope that helped.